Alright, here's the screencast for 8.3 Part 1, dots products and vector projections. So in the previous two lessons, we talked about what vectors are, what vector components are, and how to add and subtract vectors. Now, we know how to multiply a vector by a scalar, aka by a number, but it's a little different when you're multiplying two vectors together. You have to use something called a dot product. Okay. So what this means is, imagine you have two vectors, A and B, and they're depicted below. All right, here's A and B. If we shine a light on A, so a perpendicular light shining down right there, all right, so there's a flashlight, you're holding it perpendicular, you see a shadow A casts onto B. So this is going to be the shadow right here. So the length of the shadow that A casts on B is what the projection of B on A is equal to. Okay, so I gotta add a little vector. So this is the length of the shadow. Now we don't use the term shadow because it's not a math term. Instead, we call it the projection of A onto B. So of A onto B, it's the projection. So if I write this out, if I take the projection of A onto B and then multiply it by the length of B, that is what we call a dot product. So that's the definition a little bit below. So literally what you're trying to see are the parallel components. All right, you're taking the parallel components. So the dot product, it's like a multiplication symbol, but if you have two scalars, two numbers, yeah, you can use the dot as a to multiply them straight across. But if you have two vectors, it's not just a simple multiplying, right? If you have two vectors and you're multiplying, then the dot means dot product. But if you have two scalars, the dot will mean just plain multiplication. So it's very subtle, but I want to make sure you understand that the dot is not a normal multiplying. All right, so the way we write it, we say A dot B. You literally say the word dot, right? This is how you say in English, A dot B. Okay. So let's go ahead and let's do an example of how you find a dot product. You take A1 B1 plus A2 B2. So you're taking the X components and multiplying together, and you add the multiplication of the Y components. So I'm going to come back to orthogonal. We're going to do the first question as an example. So I want to find the dot product of U and V. So I'm taking the dot product, and what this is going to be equal to is U1 times V1. So U1 times V1 plus, sorry, this is not a vector. Okay, it's not a vector. Sorry, it's not written as a vector up here, so we can't write it as a vector. It's just going to be a scalar, right? Remember, it's literally going to be the length. Okay, so U1 V1 plus U2 V2. All that means is we're going to be multiplying -3 times 3 and adding 4 times 6. So that's -18 plus 24. So the dot product of U and V will be 15. Let's see, did I multiply this right? Oh, 3 times 3, my bad, is -9. And when we add that, it's going to be 15. Cool. All right, so that's just a plain dot product. But what happens if the angle between the two vectors is 90 degrees, right? None of the vector A, right, if I'm shining a light right here, none can cast a shadow on B, and the dot product will equal 0 because there is no shadow. So we call the vectors orthogonal. So if you have braces, all right, you go to an orthodontist. So orthodontists try to straighten your teeth. So ortho straightens the dont, right, teeth. An orthopedist, they straighten your bones. And then the part that's gone, like if you know of a polygon, it literally means side. So ortho side literally means the sides are straight and perpendicular. They meet at 90-degree angles. So if two vectors are orthogonal, that means they have to have no shadow, no overlap, right? Orthogonal, they literally are straight sides and perpendicular to each other. So we can do the second example. Okay, so I want to take the dot product of U and V. So what that means is take the x's and multiply together and add that to the y's multiplied together. So you get -28 plus 28, that's equal to 0. right? So that means the dot product will be 0. Therefore, we know they're orthogonal, right? Another way of saying orthogonal is saying they're normal to each other. So normal means 90 degrees, right? They're perpendicular. All of these words mean the same thing, right? They're synonyms. Okay, so other properties of dot products, right? Commutative, you can have u dot v or v dot u. You can also do the distributive, right? So if I'm trying to do the dot product of u dot v plus w, you can actually do the dot product of u and v and add it to the dot product of u and w. You can do scalar multiplication, so you can multiply out the k first, right? K here, the constant, is a scalar, so maybe it's 5, maybe it's -2, but you can multiply out first. Then the dot vector 0 dot, okay, whatever. If you're taking 0 as a dot product, it's anything times 0, 0, that's chill. And then the dot product and vector magnitude relationship, if you're taking a dot product of itself, it's going to literally be the magnitude squared. Okay, so let's try to understand that one a little better. Okay, so let's say I have a vector A, right? And then I'm going to have another vector. Actually, I'm going to have the exact same vector A. How much of the shadow of A is cast onto A? Well, the answer is all of it. Literally all of it. So if I do the dot product, right, it's just going to be the magnitude times the magnitude. Oh, that's literally the magnitude squared. So another way of saying it is the magnitude is just going to be the square root of the dot product. All right, so let's go through. I'm going to show you 2 different ways to do it. All right, this is the way we normally do it, and then I'm going to show you the way with the dot product. So normally when we try to take the magnitude, we say a squared plus b squared because we're using the x and y components. All right, so the magnitude of a is just going to be, let's see, my well, I guess I could write that as x and y, right? My x component squared, my y component squared, and then the magnitude of my actual vector is the hypotenuse of my triangle. So I have -6 squared plus 5 squared. The magnitude of a is going to be the square root of 36 plus 25. That's just going to be the square root of 61. Okay. So that's the way we normally do it. So remember, we have vector A, so I have my x, I have my y, and then my magnitude is my vector A. Length, all right, and the length is root 61. That's where this is coming from, is Pythagorean theorem on triangles. Okay, let's do it the second way. Of course, you can always pause and look at the screen, write it down, and then come back. All right, let's do it the way we just were with dot products. So I'm taking a dot a. What this is going to be is -6, 5 dot -6, 5. Okay, so what we're going to do is take our x's and multiply them together. So -6 times -6 is 36. Take our y's and multiply together, so that's going to be 25. And then if I take the square root of both sides, that's just going to be the square root of 61. So therefore, the magnitude of my vector is going to be root 61, which is exactly what we found on the left side, so that's good. It checks out. Okay, if we want the angle between 2 vectors, so the angle between them, right? Not necessarily, oh, this is what the resultant angle is at, but the angle between the vectors, not of the resultant, but between. This is how we can do it. So we're actually going to derive the formula ourselves first. So remember, a dot b is literally going to be equal to the length of the projection, a onto b. So the onto is always this lower part, right? A onto b times the magnitude of b, right? So that's the length. So it's the length of the projection times the magnitude of b. Awesome. So let's see. If I have this triangle, I want to know what is the actual length of this projection. I can easily find the magnitude of b, right? If I know it's like, oh, 5, 0. Okay, cool. I can find the magnitude. Not bad at all. But I need to know the actual length of projection of a onto b. So I'm going to use cosine, because cosine of my angle is going to be the adjacent, the projection of a onto b, over the hypotenuse, which is going to be the magnitude of a, right? The length of my hypotenuse is just the magnitude of a. So that means the projection of A onto B is going to be equal to absolute value of A of the magnitude of A times cosine of theta. Okay, so if I plug that in, let's see, A dot B is going to be equal to the magnitude of A cosine theta dot the magnitude of B. Sorry, this is just a multiplication symbol. Times the magnitude of B. Since these are just numbers, magnitude, I can just multiply them all together. Okay, so the dot product, I'm just going to write everything front here. So I have the magnitude of A times the magnitude of B times cosine theta is going to be the dot product. If I'm trying to solve for theta, trying to solve for the angle, you divide both sides by the magnitude. So I have the dot product of A and B divided by the magnitude of A times the magnitude of B, and that's going to be cosine of theta. So of course, if you want to, solve for theta, it's going to be the cosine inverse of the dot product over the absolute magnitude of both vectors. All right, and that's all. That's where this comes from. So showing you where it comes from, I mean, clearly you don't have to memorize it because you're going to have a take-home test on it since we're in the, no school for the next 2 weeks, at least in person. So this is, so you'll definitely have this when you take your test because it's open notes, open book, so you can have this formula. You don't have to memorize it. All right, so this is the angle between two vectors. So let's do the example, and then that will be where we'll end for the first screencast. So find the angle between these two vectors to the nearest tenth of a degree. So I have an angle A, angle B, and I want the angle between them. So remember, we're going to use, oops, come on. So we're going to have cosine of theta is equal to the dot product over the magnitudes of my two vectors. So I have angle, sorry, I should be writing U. I'm just writing the equation. Okay, okie dokie. So a couple things I need. I need to know what is the dot product. I need to know what is the magnitude of U and what is the magnitude of V. Once I find these, I can plug them in. Now remember the dot product, we take our x's and multiply it. So 2 times 1, so 1 times 2 plus -4 times 6. So that's 2 minus 24 is going to be -22. And the absolute, let's see, the magnitude of U is just going to be 1 squared plus -4 squared and square root. Square root of 17. And then V is going to be the square root of 2 squared plus 6 squared. So 4 plus 36, so square root of 40. All right, now I have everything, so I'll plug in. So I have -22 over square root of 17 times 40. Since a square root times square root, I can just, multiply them underneath. Okie dokie, artichoke. All right, so if that's what cosine theta is, that means theta is going to be cosine inverse of -22 over, let's see, square root of 680, square root 680, and you get theta is going to be 147.6 degrees. You just have to plug this guy into your calculator. All right, so what this means. All right, my first angle, right? 1, -4. So I go over 1, down 1, 2, 3, 4. It's about right here. This is my first angle. Oh my god, so bad. Ah! Okay, this is my first angle, and that's U. Here's my second angle, 2, 6. So 1, 2, 1, 2, 3, 4, 5, 6. Somewhere like that. All right, that's V. And if we want the angle between, it's literally this angle right here, and that's going to be 147.6 degrees. Of course, I'm not the best artist, but you can see it's about 147, more than 90. Okay, so that's where we'll end the screencast for today, and then the next screencast will finish out the rest of the lesson. So as far as homework, you should be able to do 1 through 7. Yes, you should be able to do 1 through 7. Awesome.